Okay, if you're just joining me, hi, I'm Ethan Kwan, and today I'm going to be showing you about the 3 types of radiation, and this time I'm going to talk about exponential decay. This is part 2. So last time we covered the 3 main types of atoms: alpha, beta, and gamma. Alpha decay is basically an atom of helium without the electrons. Beta decay is an electron, and gamma decay is a wave, let's just say. Now I'm going to talk about exponential decay. So let's take a simple carbon. No, let's take let's take carbon. So carbon, let's say we take carbon 14, and this is of course 8. So that means it has, no wait, this is 6. No wait, okay, so let's take carbon 14. So carbon 14 is interesting because it's one of the first atoms that are radioactive. A radioactive particle gives off an alpha, beta, or gamma particle. What does a carbon atom give off? I don't know. Can you leave it in the comments below, please? Anyway, so carbon 14 is a radioactive particle, and its half-life is about 5,000 years. I'm going to put it in quotes so you learn about it. So its half-life is about 5,000 years. Now, what is a half-life? It's the time that it takes for half of the atoms for it to disappear. So, for example, if you have 100 atoms of carbon 14, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, you know what? I'm just going to draw a bar. And let's say this is n atoms of carbon 14. So there are n atoms of carbon 14 in here. Now, let's say n is equal to 100. So there are 100 atoms of carbon 14 atom in here. So after 5,000 years, what do you expect by the title? Well, here's a kind of good representation. Half of the atoms would be turned into I think it's beta decay. Half of the atoms would have turned into a different particle, which is nitrogen, I think. Yeah. I don't know. Oxygen or nitrogen? Probably nitrogen. I don't know. Never mind. If it's neither, just tell me. Okay, so this half would have turned into carbon 14 after a little. After 2 half-lives, which is 10,000 years, about, half of that would have disappeared. So we would have 25% of our original sample. Right? Now, after 3 half-lives, 15,000 years, half of that would be gone, and it would be half of 25% left. Got it? So it's half of half of half, and so on. So let's take an atom. Let's again take an atom of carbon 14 and talk about exponential decay. So here is 10,000 years. Wait, what? No, let's say that's 100 atoms, and then that's 500 atoms, and so on. So let's say we have 4 atoms of carbon 14. 4, 3, 2, 1. And this is our time, so 5,000 years, 10,000 years, 15,000 years, 20,000, and so on. What would have happened if we have 4 atoms of carbon-14? Well, after 5,000 years, half of it would be gone. So at time equals 0, it would be at 4. Now, after 5,000 years, half of it would be gone, or right here. Okay, now again, another 5,000 years, or 10,000 years, half of that would be gone, or right here. And then let's say we go to 15,000. Okay, so then half of this would be left. Okay, so here's the graph. So at 4 half-lives it would do that, and then it would actually just kind of curve off at the end. And the reason is it's never going to be exactly 0. So I'm going to ask this question. When, let's say I have 1 atom of carbon-14. Now, I want you to think about this 1 atom of carbon-14 and think about when it would disappear and tell me when it's going to disappear. Like, how many years? Well, you can't tell because it could have disappeared right away after 1 second because it was like the super unstable one that decayed after 1 second. Or it could be 10 million years and it still could be carbon-14. Maybe it was this really lucky super special one that was super stable, and that's why it lasted 100,000 years or a million years. So you can't exactly tell. Well, I hope you enjoyed this video of radioactivity and half-lives. If you want more videos like this, make sure to subscribe, wait, what? No. Subscribe, please. Subscribe. Okay, so here's the subscribe button. Subscribe. So make sure to like. Oops. Make sure to like, subscribe, and hit the notification bell to be updated of new videos. Okay, so see you at howtodostufwithethan.com, and also if you can't make it to the website, see you next time.